Hey guys, this is Mr. Gilbert, coming at you with lecture 2 on simple machines. Normally I would do this lecture after power and work, but given that you guys are starting your Rube Goldberg project, I want to give you plenty of time to do that. I thought I should jump into machines first. If you look below, you should see guided notes below there as well. I think most of you figured this out, but I got a few texts and emails yesterday. Your guided notes are for you to use for future assessments. I do not need those turned in. So a couple of you texted and emailed your answers. No big deal. I just don't need those. Those are for you to use later. They will come in handy when we get to an assessment. Feel free to work ahead on stuff. I have most of the assignments for the next week and a half posted. I think there's one other lecture that's not posted, but the rest should be there. And feel free to work ahead on those. I think the worksheets are ready for the math practice. Again, all the math problems that are there are Algebra 1. They usually just have 3 variables, 2 or 3 variables. So if you need help, let me know. But the answers are worked out in front of you on all those, just so you're aware. So getting into simple machines, most of it is stuff that, the introductory part of it, most of it is stuff that you've learned somewhere along the way. It's just a matter of breaking them down. So where maybe you learned about a lever before, we're learning about 3 classes of levers. So we'll be adding some steps maybe to what you've learned before, but it should mostly be a review. So simple machine is defined as something that is a machine that does work with only one movement. A simple machine does work with only one movement. So it makes doing work easier by doing one of 2 things, either increasing the force or increasing the distance, one or the other. So by taking your distance and shoring it up, it can increase the force, or by making it a longer distance, it makes it a smaller force, or by making it shorter distance, it increases the force, one or the other. So the work is the same. So what you, generally speaking, what you put in, let me pull up my brush here. So the work you put in is approximately equal to the work you put out. The work input is equal to the work output. Now we lose some due to friction and wasted energy and other things, but generally what we put in is what we get out. So it doesn't change how much work there is. The force times distance you put in is equal to the force times distance that you put out. All right. So work is force times distance. Amount of force, a push or pull over a distance, is the same in or out. I'm getting a little rain here, so there might be a pause in the video. And so there are 4 ways I divide those up. The first one is levers. A lever is a bar that is free to pivot or turn around a fixed point. A lever is a bar that is free to pivot or turn around a fixed point. So there are 3 classes of levers. So normally when we think of a lever, we think of a first class lever, and that is like a pry bar. So you picture like a teeter-totter or someone trying to break into a house with a crowbar. Those are first class levers. So each lever has 3 parts. There's an input, an output, and a fulcrum. So in a first class lever, so I tell students remember them as FOI. All right, it's FOI, F-O-I, FOI. I'm going to pull my phone up here a little closer to me so I can write a little better. So FOI, F-O-I. So this is a first class lever, a second class lever, and a third class lever. FOI. So in the middle on this one, you have an input, an output, and the fulcrum is in the middle. The fulcrum is a rotating point of a lever. So you have an input on one end, the rotating point, and the output. So if you picture you opening a can of paint with a paint can opener, or even with a screwdriver, you're pushing on one end, something's coming out on the other end, and you're rotating over the lip of the paint can. That's the rotation points in the middle. So FOI, the fulcrum, is in the middle, the rotation point. A second class lever we represent with O in that acronym. All right. So in the second class lever, the output is in the middle. So we have the output is in the middle. Usually we're going to be inputting here. So input, and the fulcrum, the rotation points, the triangle is a rotation point. The fulcrum, F, all right, is going to be there. And so an example of that is a wheelbarrow. So second class lever example is a wheelbarrow, and that's where we're lifting on the handles. The stuff we're trying to move is in the middle, and then it's rotating over the far end, over the wheel. All right, so input is on one end, the fulcrum's on the other end, the middle is the O. So these letters, again, FOI, represent what's in the middle of them. And then the third one, the input's in the middle. And so we're going to have this, we have the fulcrum on one end, again, the input in the middle, and the output on the other end. Now that's kind of a weird, one. We don't normally think of levers that way. That's a third class lever. So if you picture somebody swinging a baseball bat, and a lot of times it'll be kind of a combined of your body. A lot of people use body parts as an example of third class levers, because there's a containment. So there's only so much the way that is done. So a lot of times it'll be with an instrument. So if you picture using using a baseball bat or a tennis racket or something of that nature, where my body, if I'm swinging a baseball bat, you're rotating around the player. It's actually past the bat itself. You're rotating around the player. Or swinging a tennis racket, you're rotating at the body. It's where it spins. So that fulcrum, I'll circle here, this is where you would rotate the body, swinging a bat of some sort. All right, and the input, where your hands are, is where the power is. That's where we're inputting. So it doesn't matter, again, tennis racket, baseball bat, whatever, the power, the input is in the middle, and then where you're actually contacting the ball is the output down here on the other end. So again, that is kind of all working as one machine. So again, those are 3 types of levers. And then let's get into pulleys. Pulleys are defined as a grooved wheel with rope, chain, or cable running along it. It's basically where we can redirect or multiply force by using a rope and a wheel. That's a pulley, a grooved wheel with a rope, chain, or cable running along it. So there are 3 types of pulleys. Again, maybe in elementary and middle school you just learned pulley. There are 3 types of pulleys, to be more accurate. So the 3 types of pulleys, we have a fixed pulley, which is like a single pulley attached to a spot. So if you will picture, for a fixed pulley, just what we normally think of as a pulley is hoisting something up in the air. So we have a pulley attached up in the air, and a rope on one end and a box or something on the other end, a standard pulley. That is going to be a fixed pulley. So we have a ceiling and the ground. All right, and we have you standing here pulling a rope, and that rope is attached to a pulley. We're picking up some box. All right, that is a single fixed pulley. I also think that's the best drawing I've ever had. The second type is a movable pulley, a pulley in which the end of the rope is fixed and the wheel is free to move. I'm not even going to attempt to draw that. I'll put a picture on the optional notes. But a movable pulley is a pulley in which one end of the rope is fixed. All right, and I'll go ahead and attempt. All right, so one end of the rope is fixed. I have a rope here, and I have a pulley here, and I'm pulling this up. For whatever reason, all right, I'm pulling this up, and this is the pulley here, and it's allowing me to pull that object up more easily. All right. So as a fixed pulley, again, I'll post a picture of these on the guided notes. And so that's a movable pulley. Sorry, it's a movable pulley. The third type is a block and tackle. You also hear, so we have fixed pulley, movable pulley, and the third type is a block and tackle, or you'll also hear it called a multiple pulley system. So a block and tackle or a multiple pulley system is a system of pulleys consisting of both fixed and movable parts. Usually we see a block and tackle or a multiple pulley system in terms of like lifting a boat. You see them a lot at marinas, or when they're lifting or hoisting a boat. There's rumors of that happening with Archimedes lifting a ship by himself to impress a king. But usually it's where we're lifting something really, really heavy, and we have less people to do it, and so we need to really, really redirect that. So that's a multiple pulley or block and tackle system. The third, so we have levers. There's 3 types of those, first, second, and third class. We have pulleys, fixed, movable, and block and tackles. The third simple machine group we call a wheel and axle. And a wheel and axle is defined as it consists of a shaft or axle attached to the center of a larger wheel and rotate together. So an examples of these would be gears. A lot of times faucets are made this way, doorknobs, and actually a screwdriver. Now, if we think of a screwdriver in terms of like prying a paint can open, that's a lever. Don't think of that. But when we turn the handle of a screwdriver, so if this pin is my screwdriver and I go to turn it, I'm usually turning a big circle to turn a smaller circle. When we turn something large to turn something smaller and focus our efforts, that's a wheel and axle. All right, so when I turn my steering wheel, actually in my car, that, if you picture like on a cartoon, maybe like the Flintstones, we turn a big wheel, right? We turn the big wheel and it turns the smaller circle, the smaller cylinder underneath. That's a wheel and axle. All right, so anytime we turn a bigger or smaller cylinder or circle to turn the other one, that's gonna be the case. Same is true with valves. Like if I turn a valve to turn my hose on and off, I'm turning that bigger circle to turn a little bitty valve inside, turning a big circle to turn a smaller circle. That is a wheel and axle. Fourthly, inclined planes. That's the last type. So the fourth type. There are two side branches of this. So inclined plane is defined as a sloping surface that reduces the amount of force required to do work. Inclined plane is a sloping surface that reduces the amount of force required to do work. Now, there are two side branches. So basically, if you will, a ramp is a general inclined plane would be like a ramp. So it's easier to put something up in the bed of a truck if we have a ramp. Why? We don't have to lift something quite so high. We can walk up the ramp and put it in. It requires less out of us, less force at a given time. All right, so it's an inclined plane just in general is a ramp, but there are two side parts, two annotations under that. One is a screw. A screw is actually an inclined plane wrapped around a pole, wrapped around a cylinder. So if you picture a screw, it's just literally an inclined plane, a ramp going around and around and around to get to the top of the screw. So any kind of screw, any kind of circular ramp would be considered a type of an inclined plane. And then the last one's a wedge, an inclined plane with one or two sloping sides. And a wedge, just think of an axe, think of a meat cleaver. Anytime we're cutting, for the most part, we're going directly into something. If you just picture using a meat cleaver to chop an apple or some carrots real quick in a restaurant, that can be considered a wedge. Or an axe is another good example. So again, levers, pulleys, wheel and axles, inclined planes. Those are your four general types, and then we've broken them into the smaller types. The last definition I'll give you today is a compound machine. A compound machine is where we have two or more simple machines that operate together. And that could be something really simple. A pair of scissors. A pair of scissors usually consists of two first-class levers. They're rotating in the middle. That fulcrum is in the middle. And two wedges where each blade has a wedge on it. So it's usually considered four simple machines together. That's a compound machine. A pair of tweezers is two third-class levers. You're pushing in the middle, it's rotating on the end near you, and the end on the far side is where it's outputting. That's an example. And I'll put a couple of these on the notes page as well. But a compound machine can be really simple like those, or it can be something like a bicycle. A bicycle has several different types of simple machines involved, but it's still just a compound machine. And so those are a few examples. Let me know if you guys have questions. Feel free to email me, call me, text me. Most people have been texting or emailing. That's fine. Whenever. But fill out those guided notes and just keep them for yourselves for your assessment. That'll be in like a week or two. I had a couple questions about your Rube Goldberg, which is assigned, I think, technically tomorrow. Most of you start working on it or thinking about it already. But you may work with people from other classes. I clarified that later in the day last Friday. You can work with people from other classes. In fact, I had somebody ask about working with people from Miss Mead's class or Mr. Gilbert's class. That's fine. We'll make that work. I think it doesn't matter to us so much on that. It should be good. We'll work out the grading on our end. We want to be as flexible as we can, understanding that not leaving the house, I'm not letting my kids go to the friend's house down the street or anything. So feel free to have your parents help you and that kind of thing if you want. And really, I'd like them due by that date given, but even if we need to be flexible on the date, we'll be flexible on the date. Like as far as people having trouble uploading them and that kind of thing, we'll work it out. Just get it done at some point. All right. Thanks, guys.